You step outside on a clear night, gazing up at the stars, and feel a sense of awe at the vastness of the universe. But here's the thing, what you're seeing, the stars, the galaxies, even the light itself, makes up only 5% of everything that exists. The rest, a staggering 95% of the universe, is made up of dark matter and dark energy, forces we can't see, can't touch, and barely understand. It's like trying to read a book where most of the pages are invisible, and that's just the beginning. The cosmos is filled with mysteries so strange, so mind-bending, that they defy everything we think we know about reality. From black holes that warp time to particles that can be in two places at once, the universe is far more bizarre than we ever imagined. In this video, we'll uncover 25 signs that reveal just how strange and mysterious the universe truly is. These aren't just fun facts, they're clues that challenge our understanding of existence itself. So, if you're ready to explore the edges of what we know and peer into the unknown, let's dive in. The universe is waiting, and it's stranger than you think. The first sign that our universe is far stranger than we ever imagined begins with a discovery that turned our understanding of the cosmos upside down. In the early 20th century, astronomer Edwin Hubble made an astonishing observation. Galaxies were moving away from us, and the farther away they were, the faster they seemed to be receding. This wasn't just a random scattering of motion, it was a pattern, a cosmic fingerprint that revealed something profound. The universe wasn't static, as many had believed for centuries. It was expanding. This revelation shattered the old idea of a fixed, unchanging cosmos and gave birth to a revolutionary theory, the Big Bang. If the universe is expanding, then rewinding the clock suggests that everything we see today, stars, galaxies, even space itself, must have originated from an incredibly dense hot point billions of years ago. That moment, the Big Bang, was the spark that set the stage for everything we know. But the story doesn't end there. The expansion of the universe isn't just a slow, steady drift. It's accelerating, driven by a mysterious force we call dark energy. Imagine space itself stretching, pulling galaxies apart like dots on the surface of an inflating balloon. Over time, this acceleration will cause galaxies to drift so far apart that they'll fade from each other's view, leaving the night sky eerily empty for civilizations of the distant future. And here's where things get even more intriguing. If the universe is expanding, what lies beyond the edge of what we can see? Our observable universe is like a bubble, limited by the distance light has had time to travel since the Big Bang. But what's outside that bubble? Is there more space, more galaxies, even more universes? These questions push the boundaries of our imagination, hinting at a reality far vaster and more mysterious than we can currently comprehend. So, as we stand here on our tiny pale blue dot, gazing into the endless expanse, we're left to wonder, what other secrets does the cosmos hold? The expanding universe is just the first clue, a doorway into a realm of endless possibilities. And as we step through that doorway, we'll encounter even more astonishing signs that the universe is far stranger and far more wondrous than we ever dared to dream. Have you ever wondered how much of the universe we can actually see? It turns out our view of the cosmos has a built-in limit, one that's dictated by the speed of light. This is what scientists call the cosmic horizon. Imagine standing on a beach watching a ship sail away. As it moves farther out, it eventually disappears beyond the curve of the Earth, hidden from your sight. In a similar way, our universe has a horizon, a boundary beyond which light hasn't had enough time to reach us since the beginning of time. This means that no matter how powerful our telescopes become, there's a vast portion of the cosmos that remains forever out of reach. But here's where it gets even more fascinating. The light that does reach us carries secrets from the distant past. Take the cosmic microwave background radiation, for example. This faint glow, discovered in the 1960s, is like a snapshot of the universe when it was just 380,000 years old. It's the oldest light we can observe, and it gives us a glimpse into the conditions of the early universe. Yet, even this incredible relic only scratches the surface. Beyond it lies a realm we can't see, a cosmic frontier that might hold answers to questions we haven't even thought to ask. So, what does this mean for our understanding of the universe? It's a humbling reminder that, despite our technological advancements, we're still peering through a keyhole into an unimaginably vast and mysterious expanse. And just like that ship disappearing over the horizon, the universe seems to hold back its deepest secrets, teasing us with glimpses of what might lie beyond. But as we'll see next, there are other forces at work in the cosmos, forces that are invisible, yet shape everything we see and experience. What could they be? The journey into the strange and unknown is just beginning. Picture this, a force so powerful that it shapes the very structure of our universe, yet remains entirely invisible to us. This is the enigma of dark matter, one of the most perplexing mysteries in modern astrophysics. We can't see it, touch it, or detect it directly, yet its presence is undeniable. How? Because its gravitational influence is everywhere. Galaxies spin faster than they should, and massive galaxy clusters behave as if they're being pulled by an unseen hand. Without dark matter, the universe as we know it simply wouldn't make sense. Think of it like this. Imagine you're at a party, and you hear laughter and chatter coming from a room, but when you look inside, it's completely empty. You can't see the guests, but their presence is unmistakable. That's how scientists infer the existence of dark matter. By studying the way galaxies move and interact, they've concluded that there must be something out there, something invisible exerting a gravitational pull. In fact, dark matter makes up about 27% of the universe's total mass and energy. Ordinary matter, the stuff we can see and touch, that's less than 5%. The rest is dark energy, which we'll get to later. But what exactly is dark matter? That's the million-dollar question. For decades, researchers have been searching for clues, trying to piece together the nature of this elusive substance. Some theories suggest it's made up of particles that don't interact with light or ordinary matter, making them incredibly difficult to detect. Experiments deep underground, in abandoned mines and beneath mountains, are hunting for these hypothetical particles. Others propose that dark matter might be something even stranger, like tiny black holes formed in the early universe or exotic particles we've yet to imagine. The discovery of dark matter would revolutionize our understanding of the cosmos. It could explain how galaxies formed, why the universe looks the way it does, and even shed light on the fundamental forces that govern reality. But for now, dark matter remains a tantalizing mystery, a cosmic puzzle waiting to be solved. And yet, as strange as it is, dark matter is just the beginning. It's a reminder that the universe is far more mysterious than we often realize, and that there's so much more waiting to be uncovered. Picture this, the universe isn't just expanding, it's accelerating. Galaxies are racing away from each other faster and faster, as if some unseen hand is pushing them apart. This mysterious force is called dark energy, and it's one of the greatest puzzles in modern science. Even though it makes up about 68% of the universe's energy content, we still don't know what it actually is. It's invisible, undetectable by our instruments, and yet its effects are undeniable. So, what exactly is dark energy? One leading idea is that it's tied to something called the cosmological constant, a concept first introduced by Albert Einstein. He originally added it to his equations to keep the universe static, but later discarded it as his biggest blunder. Ironically, it might be the key to understanding why the universe isn't just expanding but speeding up. Essentially, the cosmological constant suggests that empty space itself has energy, a kind of background hum that's constantly pushing everything apart. But there's another intriguing possibility, quintessence. Unlike the cosmological constant, which remains steady, quintessence is a dynamic force that could change over time. Imagine it as a cosmic field, ebbing and flowing, subtly influencing the universe's expansion. Some scientists even speculate that quintessence could one day reverse its effects, causing the universe to collapse. What's truly mind-bending is the scale of dark energy's influence. It's not just a gentle nudge, it's a relentless push, overpowering even gravity on the largest scales. As a result, galaxies are drifting apart faster than ever, and over time, the universe could become a much lonelier place. This invisible force is literally shaping the fate of everything we see, and yet it remains completely beyond our grasp. And here's where things get even stranger. Dark energy doesn't just exist in isolation, it's locked in a cosmic tug of war with gravity, the force that holds galaxies and stars together. This interplay creates some of the most bizarre phenomena in the universe, from the formation of vast cosmic voids to the stretching of space itself. But what happens when these forces collide on an even grander scale? That's where our next sign takes us, into a realm where the very fabric of reality bends and warps in ways that defy imagination. Black holes are perhaps the most enigmatic and awe-inspiring objects in the universe, where the rules of physics as we know them seem to break down completely. Picture a place where gravity is so intense that nothing, not even light, can escape its grasp. These cosmic behemoths form when massive stars, many times larger than our Sun, exhaust their nuclear fuel and collapse under their own gravity. The result, a region of space so dense that it warps the very fabric of reality around it. What's truly fascinating is that black holes aren't just destructive forces, they are also architects of the cosmos. At the heart of nearly every galaxy lies a supermassive black hole, millions or even billions of times more massive than our Sun. These titans play a crucial role in shaping the galaxies they inhabit, influencing the movement of stars and gas, and even triggering the birth of new stars. Without them, the universe as we know it might look entirely different. In recent years, our understanding of black holes has taken a giant leap forward. In 2019, scientists captured the first ever image of a black hole's event horizon, the point of no return where light vanishes forever. This groundbreaking achievement, made possible by the Event Horizon Telescope, gave us a glimpse into the shadowy heart of a black hole 55 million light-years away. But even with this milestone, black holes remain shrouded in mystery. At their core lies a singularity, a point of infinite density where the laws of physics as we understand them simply cease to apply. What happens there we don't yet know. To wrap your mind around their immense power, think of black holes as cosmic vacuum cleaners, relentlessly pulling in everything that strays too close. Yet they're far more than just destructive forces. They're also windows into the universe's deepest secrets, gateways to phenomena we can barely begin to comprehend. And speaking of gateways, black holes might just lead us to even stranger cosmic wonders, phenomena that challenge our understanding of space, time, and existence itself. Imagine a cosmic shortcut, a tunnel that bends the very fabric of space and time, allowing you to traverse unfathomable distances in the blink of an eye. This is the tantalizing idea behind wormholes, theoretical passages through spacetime that could connect two distant points in the universe. Born from the mind-bending equations of Einstein's general theory of relativity, wormholes are like cosmic bridges, offering a way to bypass the vast emptiness of space. But here's the catch: while the math suggests they could exist, we've yet to find any evidence that they're real. So, how do they work? Picture spacetime as a sheet of paper. If you fold that paper so two distant points touch, a wormhole would be like poking a hole through the fold, creating a direct path between them. It's a shortcut through the universe, but one that comes with enormous challenges. For starters, wormholes are incredibly unstable. Without some exotic form of matter or energy to hold them open, they'd collapse almost instantly. and even if we could stabilize them, the journey through a wormhole would be anything but simple. The intense gravitational forces could tear apart anything that dared to enter, making them more of a theoretical curiosity than a practical travel option, at least for now. Yet the possibilities are mind-blowing. Wormholes could offer a way to travel not just across space, but through time itself. Imagine stepping into a wormhole and emerging in a distant galaxy, or even in a different era of the universe's history. It's the stuff of science fiction, but it's rooted in real physics. And while we're far from harnessing this potential, the very idea of wormholes opens up a universe of questions about the nature of reality and the limits of human exploration. What's even more fascinating is how wormholes hint at the strange quantum underpinnings of the cosmos. They remind us that the universe is far more interconnected and far stranger than we once thought. As we delve deeper into the mysteries of space-time, we're left wondering, could wormholes be the key to unlocking the secrets of the cosmos, or are they just a tantalizing mirage in the desert of theoretical physics? Either way, they're a reminder that the universe is full of surprises, waiting for us to uncover them. And speaking of surprises, this strange interplay of space, time, and quantum weirdness brings us to our next sign, a phenomenon that challenges everything we think we know about reality itself. Picture two particles separated by billions of light years, yet somehow intimately connected. If you change the state of one, the other instantly responds, no matter how far apart they are. This isn't science fiction, it's quantum entanglement, one of the most baffling and beautiful phenomena in the universe. It's as if the cosmos has its own invisible threads, weaving particles together in ways that defy everything we thought we knew about space, time, and reality itself. At the heart of quantum entanglement is a concept that shakes the very foundation of classical physics. In our everyday world, objects interact through forces and signals that travel at finite speeds. But entangled particles seem to break these rules, communicating instantaneously across vast distances. Albert Einstein famously called this spooky action at a distance, because it challenges the idea that nothing can travel faster than light. Yet, experiments have repeatedly confirmed that entanglement is real, pushing us to rethink the nature of reality itself. What's even more fascinating is how this strange phenomenon isn't just a curiosity, it's a cornerstone of cutting-edge technologies. Quantum entanglement is the key to quantum computing, where particles work together in ways that could solve problems far beyond the reach of classical computers. Imagine cracking code, simulating complex molecules, or optimizing systems in seconds. Entanglement makes it possible. It's also the foundation of quantum communication, promising ultra-secure networks where information is transmitted almost instantaneously with no fear of interception. But entanglement doesn't just exist in the lab, it's woven into the very fabric of the cosmos. Scientists believe that the universe itself might be entangled on a grand scale, with particles and galaxies connected in a vast cosmic web. Think of it like a tapestry where each thread represents a connection between distant points in space. This cosmic entanglement could explain how the universe grew from a tiny, dense point into the sprawling expanse we see today, all while maintaining a hidden unity that binds everything together. Quantum entanglement reveals a universe that's far stranger, far more interconnected than we ever imagined. It challenges our understanding of reality, showing us that the cosmos operates on rules that seem almost magical. And as we peel back these layers of mystery, we're left with a profound question. If particles can be so deeply connected, what does that mean for the nature of existence itself? The answers may lie in the next sign, where we'll explore another mind-bending phenomenon that stretches the limits of our imagination. What if our universe isn't as unique as we think? Picture this, a vast cosmic tapestry, not just one universe, but an endless array of them, each with its own rules, its own stars, and perhaps even its own versions of you and me. This is the mind-bending idea of the multiverse, a concept that suggests our universe is just one thread in an infinite fabric of parallel realities. Theories like inflationary cosmology propose that our universe is merely one bubble in a cosmic foam, with countless other bubbles floating alongside it, each expanding and evolving in its own way. Meanwhile, string theory takes it even further, suggesting that these universes could exist in higher dimensions, stacked like pages in an unimaginably vast book. But here's where it gets even stranger. In some of these universes, the laws of physics might be entirely different. Imagine a universe where gravity is 10 times stronger, making stars burn out in mere millions of years. Or one where the speed of light is slower, turning the cosmos into a sluggish, slow-motion dance. The possibilities are as endless as they are fascinating. And then there's the idea of parallel realities, universes where every decision you've ever made branches off into a new timeline. Did you take a different job, move to a new city, or even exist in a completely different form? In the multiverse, all these versions of you could be playing out simultaneously, like an infinite number of cosmic reruns. But as we marvel at the sheer scale of this idea, it raises a profound question. Why does our universe have the precise set of physical laws that allow life to exist? This fine-tuning, this delicate balance of constants and forces, is one of the greatest mysteries of all. And it's a mystery that leads us to the next sign, a clue hidden in the very fabric of our reality. Have you ever stopped to think about how precisely the universe seems to be arranged just right for life to exist? It's almost as if someone or something set the dials on the cosmos with incredible care. This brings us to the ninth sign that our universe is far stranger than we imagine, the fine-tuning problem. The fundamental constants of nature, things like the strength of gravity, the speed of light, and the cosmological constant, are so finely balanced that even the tiniest change would make life as we know it impossible. Take gravity, for example. If it were just slightly stronger, stars would burn out too quickly, leaving no time for planets to form or life to evolve. If it were weaker, stars might not even ignite in the first place. It's a cosmic Goldilocks scenario. Everything has to be just right. This precision has led scientists to propose the Holographic Principle, which suggests that the universe must be compatible with the conscious life that observes it. But here's where it gets really intriguing. Is this fine-tuning simply a lucky coincidence, or could it point to something deeper, perhaps even intentional design? Some argue that it's evidence of a multiverse where countless universes exist with different constants, and we just happen to live in the one where everything lines up perfectly. Others see it as a hint that there's a grander purpose or intelligence behind the cosmos. The cosmological constant, which governs the expansion of the universe, is another jaw-dropping example. If this number were even slightly different, the universe would either collapse in on itself or expand so rapidly that galaxies, stars, and planets could never form. It's mind-boggling to consider how delicate this balance truly is, and yet here we are in a universe that seems tailor-made for life. But what if this fine-tuning isn't the end of the story? What if it's just the tip of the iceberg, pointing us toward even greater cosmic mysteries waiting to be uncovered? Now, let's take a moment to ponder one of the most perplexing questions in all of science. If the universe is so unimaginably vast with billions of stars and planets, why haven't we found any evidence of extraterrestrial life? This is the heart of the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" On paper, it seems almost inevitable that intelligent life should exist somewhere out there. Yet, despite decades of searching, the cosmos remains eerily silent. One possible explanation is that intelligent life is extraordinarily rare. Perhaps the conditions needed for complex civilizations to arise are so specific that Earth is one of the very few, or even the only planet where it has happened. Or maybe advanced civilizations do exist, but they're so far beyond our understanding that we simply can't detect them. Imagine a species so advanced that they've mastered technologies we can't even begin to comprehend, rendering them invisible to us. Another chilling possibility is that advanced civilizations might choose to hide. Think about it. If a species developed the ability to travel across galaxies, they might also develop the wisdom to stay hidden, either to avoid conflict or to protect less advanced civilizations like ours from the shock of contact. Or perhaps they've evolved beyond the need for physical forms, existing as energy or in dimensions we can't perceive. So, are we truly alone, or is the universe teeming with life that's just beyond our ability to detect? The Fermi Paradox doesn't give us answers, it only leaves us with more questions. But one thing is certain, the possibilities are as strange as they are limitless. And speaking of strange possibilities, let's dive into the next sign, where we'll explore the mind-bending idea that life might exist in forms we've never even imagined. When we think about life, we often picture the lush forests, vast oceans, and vibrant ecosystems of Earth. But what if life doesn't need those familiar comforts to survive? Enter extremophiles, organisms that defy our expectations by thriving in some of the most hostile environments on our planet. From scorching hydrothermal vents at the bottom of the ocean to the acidic waters of volcanic lakes, these resilient creatures challenge our understanding of where life can exist. And if life can flourish in such extreme conditions here, what does that mean for the possibility of alien life elsewhere in the universe? Take Mars, for example. For decades, scientists have been captivated by the idea of life on the red planet. While its surface appears barren and inhospitable today, evidence suggests that Mars once had flowing water, a key ingredient for life as we know it. Could microbial life, similar to Earth's extremophiles, still exist beneath its icy poles or in underground reservoirs? Then there's Europa, one of Jupiter's moons, where a vast ocean lies hidden beneath a cracked, icy shell. The tidal forces exerted by Jupiter could generate enough heat to keep that ocean liquid, creating a potential haven for life. And let's not forget the thousands of exoplanets discovered in the habitable zones of distant stars' worlds where conditions might be just right for life to emerge. But here's where it gets truly fascinating. What if alien life doesn't conform to our Earth-centric definitions? What if it doesn't need water, oxygen, or even carbon-based chemistry? Imagine organisms that thrive in methane lakes, like those on Saturn's moon Titan, or creatures that harness energy from cosmic rays or geothermal heat. The universe is vast, and the possibilities for life are as diverse as the galaxies themselves. As we continue to explore these alien landscapes, both real and hypothetical, we're reminded that life may exist in forms we can't yet comprehend. And that brings us to the next sign, the idea that our universe might be stranger than we ever imagined, not just in its environments, but in the very nature of life itself. But let's shift our focus to something even more unsettling, the Great Filter. Imagine if the universe is designed like a cosmic obstacle course, filled with challenges so immense that most civilizations never make it to the finish line. This is the essence of the Great Filter hypothesis, a concept that suggests there's some kind of barrier, whether biological, technological, or environmental, that prevents intelligent life from advancing far enough to explore the stars. The question is, where does this filter lie? Is it behind us, something we've already survived, like the leap from single-celled organisms to complex life? Or is it ahead of us, lurking in the shadows of our future, perhaps in the form of self-destruction or a catastrophic event we can't yet predict? The idea is both fascinating and terrifying. If the filter is in our past, it means we've already overcome one of the universe's greatest challenges, and the stars might one day be within our reach. But if it's in our future, it could mean that every civilization reaches a point where it simply can't progress further, whether through war, environmental collapse, or some unforeseen cosmic disaster. The implications are staggering. Are we alone in the universe because other civilizations have already failed to pass their own great filter, or are we, too, destined to face a similar fate? To make this even more relatable, think of it like a video game. You start off with simple challenges, but as you progress, the levels get harder and harder. Some players quit early, while others make it to the final boss, only to fail at the last hurdle. The great filter could be that final boss, a challenge so immense that only the luckiest or most prepared civilizations survive. And right now, we're still figuring out how to beat the earlier levels. So, what would it take to overcome this cosmic obstacle? Technological advancements are key. From sustainable energy sources to AI that can help us solve complex problems, the tools we develop in the coming decades could determine whether we make it past the filter or not. But this isn't just about technology, it's also about cooperation, foresight, and the choices we make as a species. Will we rise to the challenge, or will we become another cautionary tale in the universe's grand experiment? And speaking of challenges, this leads us to the next sign, one that explores the very technologies that might help us defy the odds and reach for the stars. What if the true measure of a civilization wasn't its technology or culture, but something far more fundamental: energy? This is the idea behind the Kardashev Scale, a fascinating framework that categorizes civilizations based on how they harness and use energy. Right now, humanity sits at the very bottom of this scale, classified as a Type 0 civilization. We're still reliant on fossil fuels and renewable energy sources tied to our planet, barely scratching the surface of what's possible. But what would it take to climb this cosmic ladder, and what could a more advanced civilization achieve? A Type I civilization, for example, would have mastered the ability to harness all the energy available on its home planet. Think about it: entire continents powered by solar arrays, oceans tapped for geothermal energy, and weather systems controlled to prevent disasters. It's a vision that feels almost like science fiction, but it's the logical next step for a species determined to survive and thrive. The challenge, of course, is immense. To reach this level, we'd need to overcome not just technological hurdles, but also political, social, and environmental ones. It's a daunting task, but one that could redefine our future. Now, imagine a Type Roman II civilization. These beings wouldn't just stop at their planet, they'd tap into the energy of their entire star. Picture a Dyson sphere, a colossal structure built around a sun to capture its immense power. With that kind of energy, a civilization could achieve feats that seem impossible to us: interstellar travel, terraforming planets, or even creating artificial worlds. The scale of their ambition would dwarf anything we've ever dreamed of. And then there's Type Roman III, a civilization that has transcended the limits of a single star system. They'd harness the energy of entire galaxies, bending the cosmos to their will. What could they achieve? Perhaps they'd manipulate space-time itself, or even create new universes. The Kardashev Scale doesn't just measure energy, it paints a picture of what intelligent life could become, given enough time and innovation. What's truly mind-bending is that somewhere out there, right now, a civilization like this might already exist. The universe is vast, and the Kardashev Scale reminds us that we're just at the beginning of what might be possible. It's a humbling thought, but also an inspiring one. If we can dream of civilizations that harness the power of stars and galaxies, who's to say we won't someday join them? The scale doesn't just reveal the potential of advanced civilizations, it reveals the limitless potential of life itself. And as we'll see next, that potential might be even stranger than we've imagined. Imagine being able to step outside of time as we know it, where minutes stretch into hours or years pass in what feels like seconds. This isn't science fiction, it's a real phenomenon called time dilation, and it's one of the most mind-bending consequences of Einstein's theory of relativity. At its core, time dilation tells us that time isn't a fixed, universal constant. Instead, it flows differently depending on how fast you're moving or how strong the gravitational forces around you are. Think about astronauts aboard the International Space Station. Because they're orbiting Earth at incredible speeds and experiencing weaker gravity compared to us on the surface, time actually passes slightly faster for them. Over the course of 6 months in space, an astronaut might age about 0.007 seconds less than someone on Earth. It's a tiny difference, but it's measurable, and it's proof that time is far more flexible than our everyday experience suggests. But here's where it gets even stranger. If you could travel close to the speed of light, time would slow down dramatically for you compared to someone standing still. A trip that feels like a few years to you might mean decades or even centuries have passed back on Earth. And in the presence of extreme gravity, like near a black hole, time would stretch to the point where minutes could equal years elsewhere in the universe. These aren't just theoretical ideas. Experiments with atomic clocks on airplanes and satellites have confirmed time dilation over and over again. What does this mean for our understanding of the universe? It suggests that time itself is woven into the fabric of space, bending and warping alongside it. And if time can stretch and twist, what does that say about the possibility of time travel, or even the way we perceive reality? These questions hint at even more bizarre cosmic truths, ones that challenge everything we think we know about existence. And as we'll see next, the universe has even more surprises in store when it comes to the nature of time. Ever wondered why time seems to move in only one direction? This is the 15th sign that our universe is far stranger than we imagine, the arrow of time. Unlike space, where we can move freely in any direction, time marches forward relentlessly, carrying us from the past into the future. But why is this the case? Why can't we go backward in time, reliving moments or undoing decisions? The answer might lie in one of the most fundamental laws of physics, the second law of thermodynamics. This law states that in any isolated system, entropy, a measure of disorder, always increases over time. Think of it like a sandcastle on the beach. You can build it into a perfectly structured shape, but over time, the wind and waves will scatter the sand, increasing its disorder. In the same way, the universe tends toward chaos, and this irreversible increase in entropy is what gives time its direction. But here's where things get even more mind-bending. What if, hypothetically, entropy could decrease? Could time reverse itself? Some theories suggest that in a hypothetical universe where entropy decreases, time might flow backward. But in our universe, that's not the case. The arrow of time is firmly pointed forward, and this one-way flow is deeply tied to the very fabric of reality. This leads us to an even bigger question. Is time itself a fundamental property of the universe, or is it simply an emergent feature, something that arises from the behavior of matter and energy? The nature of time is so intertwined with the cosmos that understanding it could unlock some of the deepest mysteries of existence. And as we ponder this, we're reminded that the strangeness of our universe isn't just about distant stars or cosmic phenomena. It's woven into the very tick of the clock that governs our lives. Now, as we continue to explore the mysteries of the universe, let's turn our attention to the next sign, one that reveals how the fabric of space itself might hold the key to understanding the true nature of reality. What if everything you see, touch, and experience is nothing more than a projection, a cosmic illusion? This brings us to the 16th sign that our universe is far stranger than we imagine, the holographic principle. At its core, this mind-bending idea suggests that the entire universe, with all its vastness and complexity, might actually be encoded on a two-dimensional surface. Think of it like a movie screen where the images you see appear three-dimensional, but they're actually just flat projections. In the same way, our three-dimensional reality could be a kind of hologram, a projection of information stored on a distant two-dimensional boundary. Scientists have been exploring this concept for decades, inspired by the behavior of black holes. When matter falls into a black hole, it doesn't just disappear. Instead, its information appears to be encoded on the black hole's event horizon, the point of no return. This led physicists to wonder, could the entire universe work the same way? If so, our reality might not be as solid as it seems. Instead, it could be a kind of cosmic mirage with all the information about stars, galaxies, and even you and me stored on a flat surface somewhere at the edge of existence. This idea challenges everything we think we know about space, time, and reality itself. If the holographic principle is true, it means that the universe is like a giant cosmic computer with all its data compressed into a two-dimensional code. Our three-dimensional world would then be the result of that code being played back in a way that creates the illusion of depth and solidity. It's as if we're living inside a simulation, but one that's written on the very fabric of the cosmos. The implications of this are staggering. It could mean that our perception of reality is fundamentally limited, like watching a movie without realizing it's just a projection. It also raises questions about free will, consciousness, and the nature of existence. If everything we experience is just encoded information, what does that say about the choices we make or the lives we lead? And if the universe is a hologram, what or who is projecting it? As we grapple with these questions, we're reminded that the universe is far more mysterious than it appears. The holographic principle doesn't just challenge our understanding of reality, it invites us to rethink what it means to exist at all. And as we peel back the layers of this cosmic mystery, we're left with an even deeper question. If the universe is a hologram, what lies beyond the screen? This leads us to our next sign, which explores an even more profound and unsettling possibility about the nature of reality. What if everything you've ever known, every breath, every star, every moment was nothing more than lines of code in an unimaginably advanced computer program? This is the core of the simulation hypothesis, a mind-bending idea that suggests our universe might not be the ultimate reality, but instead a meticulously crafted simulation. The concept isn't new. Philosophers have pondered the nature of existence for centuries, but modern science has given this idea a fresh twist. Could we, and everything around us, be part of a simulation created by a civilization far more advanced than our own? The argument for this hypothesis often starts with the rapid advancement of technology. Think about how far we've come in just a few decades, from basic computers to virtual reality environments so immersive they blur the line between the digital and the real. If we can create simulations that feel lifelike now, what might a civilization thousands or even millions of years ahead of us achieve? Some scientists, like philosopher Nick Bostrom, argue that if it's possible for a civilization to create such simulations, the odds are high that we're already living in one. After all, if advanced beings can simulate entire universes, wouldn't they create countless simulations, making it statistically more likely that we're in one of those rather than the original reality? But not everyone is convinced. Critics point out that there's no concrete evidence to support the simulation hypothesis. They argue that while it's an intriguing idea, it's ultimately untestable, at least with our current understanding of physics and technology. Others suggest that the complexity required to simulate an entire universe, down to the smallest particle, might be beyond even the most advanced civilization. And then there's the philosophical question: if we are in a simulation, does it even matter? Would our experiences, emotions, and relationships feel any less real to us? This hypothesis doesn't just challenge our understanding of reality, it forces us to ask profound questions about existence itself. How would we know if we're living in a simulation? Could there ever be a glitch or an error that reveals the truth? And if we discovered we were in a simulation, how would that change the way we live our lives? These questions might seem like science fiction, but they push the boundaries of what we consider possible, inviting us to think beyond the limits of our current knowledge. As unsettling as it may be, the simulation hypothesis reminds us that our understanding of the universe is still in its infancy. It's a humbling thought, but also an exciting one because it means there's so much more to discover. And with every new discovery, we might find ourselves questioning not just the universe around us, but the very nature of reality itself. Imagine the universe not as a scattered collection of stars and galaxies, but as a vast, intricate tapestry woven from threads of light and shadow. This is the cosmic web, the grand architecture of the cosmos. Stretching across billions of light years, it's a network of filaments made up of galaxies, gas, and dark matter, connected like neurons in a cosmic brain. These filaments twist and curve, forming bridges between dense clusters of matter, while leaving behind enormous voids, vast, empty regions where almost nothing exists. It's as if the universe itself is a living organism with veins and arteries pumping the lifeblood of matter through its body. But how does this cosmic web form? It all starts with tiny fluctuations in the early universe, ripples in the fabric of space-time left over from the Big Bang. Over billions of years, gravity took hold, pulling matter together into dense knots and stretching it into long, thread-like filaments. Dark matter, the invisible scaffolding of the universe, played a crucial role, guiding the growth of this structure and shaping the paths of galaxies. What emerges is a breathtaking pattern, a delicate balance of light and emptiness, where galaxies cluster along the filaments like beads on a string, and the voids between them stretch into the unknown. The cosmic web isn't just a static structure, it's dynamic, ever-evolving. As galaxies move along these filaments, they collide, merge, and give birth to new stars, feeding the cycle of cosmic creation. And yet, for all its beauty, the cosmic web remains one of the most mysterious features of our universe. It's a reminder that even on the largest scales, the cosmos is governed by forces we're only beginning to understand. Forces that shape not just the distribution of matter, but the very fabric of reality itself. Picture this, a faint, almost imperceptible glow that permeates the entire cosmos, a whisper from the dawn of time itself. This glow, known as the cosmic microwave background radiation, is essentially the universe's baby photo, a snapshot of its earliest moments, just 380,000 years after the Big Bang. It's the afterglow of that colossal explosion, a relic of the intense heat and energy that once filled the universe, now stretched and cooled over billions of years into a faint microwave hum. To put it simply, the cosmic microwave background is like a cosmic fingerprint, a unique signature left behind by the Big Bang. Think of it as the light from a fireworks display long after the explosion has faded. The fireworks themselves are gone, but their glow lingers, and by studying that glow, we can piece together what the explosion must have looked like. In the same way, this radiation gives us a glimpse into the universe's fiery infancy, revealing the conditions that existed when everything we know was just beginning to take shape. What makes this glow so remarkable is how precisely it aligns with the predictions of the Big Bang Theory. The radiation isn't perfectly uniform, it has tiny fluctuations like ripples on the surface of a pond. These ripples are the seeds of structure in the universe, the slight variations in density that would eventually grow into galaxies, stars, and planets. Without them, the cosmos as we know it wouldn't exist. It's as if the universe left us a coded message in this ancient light, one that scientists have spent decades deciphering. But here's where it gets even more fascinating. This afterglow doesn't just tell us about the universe's past. It also holds clues to its origins. By analyzing the patterns in the cosmic microwave background, researchers can test theories about how the universe began, how it expanded, and even what might have come before the Big Bang. It's like peeling back layers of time, revealing secrets that were hidden for billions of years. And as we continue to study this cosmic echo, we're reminded that the universe is far stranger, far more intricate than we ever imagined. Every discovery leads to new questions, new mysteries to unravel. So, what other secrets might this ancient light hold? What else can it teach us about the origins of everything? The answers may lie in the next sign, where we'll explore how the universe's earliest moments continue to shape its destiny. Imagine the universe as a cosmic balloon, expanding faster than the speed of light in the tiniest fraction of a second after the Big Bang. This isn't science fiction, it's the theory of cosmic inflation, one of the most fascinating ideas in modern cosmology. According to this theory, the universe didn't just expand. It underwent an explosive growth spurt, stretching from something smaller than an atom to something unimaginably vast in less than a blink of an eye. But why does this matter? Well, inflation solves one of the universe's biggest mysteries. Why does the cosmic microwave background, the faint afterglow of the Big Bang, look so incredibly uniform across the sky? Without inflation, we'd expect to see wild temperature variations, but instead, it's remarkably smooth, like a perfectly baked cosmic cake. Inflation stretched space so quickly that it ironed out these irregularities, creating the uniform backdrop we observe today. But inflation didn't just smooth things out. It also planted the seeds for the universe's structure. As space expanded, tiny quantum fluctuations, those microscopic ripples in the fabric of reality, were stretched along with it. These fluctuations became the blueprint for everything we see today: galaxies, clusters of galaxies, and even the vast cosmic web that connects them. Think of it like blowing up a balloon with tiny dots on its surface. As the balloon inflates, the dots move farther apart, but their pattern remains, shaping the final design. In the same way, those primordial quantum fluctuations grew into the cosmic structures we now observe, all thanks to inflation. And here's where things get even stranger. Inflation suggests that our universe might be just one bubble in a multiverse, an endless sea of universes, each with its own unique properties. It's a mind-bending idea, but one that's supported by the math and observations. So, while inflation explains so much about our universe, it also opens the door to even bigger questions. What sparked this rapid expansion? And what role did those quantum fluctuations play in shaping not just our universe, but potentially countless others? These aren't just questions for scientists, they're questions that challenge our understanding of reality itself. And as we'll see next, those quantum fluctuations hold even more secrets about the universe's strange and mysterious beginnings. Now let's dive into the 21st sign that our universe is far stranger than we imagine: quantum fluctuations. Picture the universe in its infancy, a seething, chaotic soup of energy and particles. At this unimaginably small scale, tiny ripples of energy were constantly popping in and out of existence. These were quantum fluctuations, microscopic disturbances in the fabric of reality itself. But here's the wild part: these seemingly insignificant ripples didn't just vanish. Instead, they became the cosmic seeds from which everything we see today grew. As the universe expanded, these tiny fluctuations were stretched and amplified, like whispers turning into roars across the cosmos. Over billions of years, gravity took over, pulling matter together around these ripples. Denser regions became the nurseries for galaxies, while the less dense areas evolved into the vast voids we observe between them. What started as quantum jitters in the early universe eventually gave rise to the colossal structures we see today: galaxies, galaxy clusters, and even the intricate web of the cosmic network. Think of it like this: if the universe were a canvas, quantum fluctuations were the first brushstrokes, faint but full of potential. Over time, those strokes grew into a breathtaking masterpiece, with galaxies swirling like paint and clusters forming bold, intricate patterns. It's a cosmic story that ties the smallest scales to the largest, showing how the quantum realm shaped the universe on a grand scale. But what's truly mind-blowing is what this reveals about the origins of our universe. These fluctuations are a fingerprint of the quantum world, a reminder that even the vastness of space has its roots in the strange, unpredictable behavior of particles. It's as if the universe itself carries a hidden quantum signature, whispering secrets about its birth in every galaxy and star. And speaking of secrets, these quantum ripples hint at something even more profound: a connection between the tiniest building blocks of reality and the immense structures that define our cosmos. It's a clue that the universe's story is far from over, and that the quantum realm might hold even more surprises waiting to be uncovered. What happens to the universe when time itself runs out? This question has haunted scientists and dreamers alike for centuries. The universe, as vast and mysterious as it is, isn't eternal, at least not in the way we might hope. The 22nd sign that our universe is far stranger than we imagine lies in the theories surrounding its ultimate fate. Will it end in a slow, cold fade? A violent collapse, or something even more dramatic? Let's explore the possibilities. One of the leading theories is the Big Freeze, also known as heat death. In this scenario, the universe continues expanding at an accelerating rate, driven by dark energy. Over trillions of years, galaxies drift farther apart, stars burn out, and black holes evaporate. Eventually, the universe becomes a dark, cold, and lifeless void. It's a chilling thought, literally and figuratively, but the evidence for this theory is compelling, as observations of distant galaxies show the expansion of the universe speeding up, not slowing down. Then there's the Big Crunch, a dramatic counterpoint to the Big Freeze. Here, the universe's expansion reverses, perhaps due to gravity overpowering dark energy. Galaxies, stars, and even atoms are pulled back together in a catastrophic collapse, culminating in a single, infinitely dense point, a cosmic mirror of the Big Bang. While this theory is less supported by current data, it raises fascinating questions about the cyclical nature of existence. Could the universe be caught in an endless loop of expansion and contraction? Finally, there's the Big Rip, a scenario almost too strange to imagine. In this case, dark energy grows stronger over time, tearing apart galaxies, solar systems, and even atoms themselves. The universe doesn't just fade, it's violently shredded. While this theory is more speculative, it highlights the unpredictable nature of dark energy, a force we still barely understand. Each of these theories has profound implications for the future of cosmic structures and life itself. Will the universe end in a whisper or a bang, or could it be part of a grander cycle where endings are merely beginnings in disguise? As we ponder these possibilities, it's worth noting that the universe's fate is still a mystery, shaped by forces we're only beginning to comprehend. And speaking of cycles, this brings us to the next sign, a phenomenon that hints at the universe's ability to renew itself in ways we're only starting to uncover. What if the universe is not a one-time event, but instead a never-ending loop of creation and destruction? This is the mind-bending idea behind cyclic cosmology, a theory that suggests our universe is just one in an infinite series of expansions and contractions, like a cosmic heartbeat echoing across eternity. Imagine the Big Bang not as the beginning of everything, but as a moment of rebirth, a point where the universe collapses and then bounces back, starting the cycle all over again. This concept, often called the Big Bounce, challenges our understanding of time and space, suggesting that the universe might have no true beginning or end, just an endless rhythm of existence. Think of it like a giant cosmic accordion, expanding outward until it reaches its limit, then collapsing back in on itself, only to expand once more. This cyclical process raises profound questions about the nature of reality. Could time itself be cyclical, looping endlessly as the universe breathes in and out? And if so, what does that mean for our place in the grand scheme of things? The Big Bounce theory isn't just a wild idea. It's supported by some cutting-edge physics, including quantum gravity models that suggest the universe's collapse might not end in a singularity, but instead in a rebound full of potential for a new beginning. This endless cycle might also hold the key to some of the universe's greatest mysteries. For instance, if the universe has gone through countless cycles, it could explain why certain constants, like the speed of light or the strength of gravity, seem so finely tuned for life. Each cycle could be a kind of cosmic trial and error, refining the conditions until they're just right for stars, planets, and eventually us. It's a humbling thought, that we might be the product of an infinite series of cosmic experiments, each one bringing the universe closer to the conditions we know today. But cyclic cosmology doesn't just challenge our understanding of the universe, it also raises questions about the nature of time itself. If the universe is cyclical, could time itself loop back, creating a kind of eternal return? It's a concept that has fascinated philosophers and scientists alike, blurring the line between the physical and the metaphysical. And as we explore these ideas, we're reminded that the universe is far stranger and more mysterious than we can imagine, a place where even time might not be what it seems. As we ponder the endless cycles of the cosmos, it's hard not to wonder what other secrets the universe might be hiding. Could these cycles hold the key to unlocking its deepest mysteries? And if so, what might we discover as we continue to explore the vast, pulsating rhythm of existence? What if the universe itself is shaped by the very act of observation? This brings us to the 24th sign, a concept that challenges everything we think we know about reality, the role of consciousness. Some scientists and philosophers suggest that consciousness isn't just a byproduct of the universe but a fundamental force that shapes it. Imagine that for a moment our awareness, our ability to observe and interpret the cosmos, might actually influence the fabric of existence itself. This idea is central to the participatory universe theory, which proposes that the universe requires conscious observers to bring it into being. It's a concept that feels almost like science fiction, but it's rooted in some of the most intriguing interpretations of quantum mechanics. For instance, in experiments like the double-slit experiment, particles behave differently when they're being observed versus when they're not. This has led some to wonder, does the universe exist because we're here to witness it? Or to put it another way, could consciousness be the key that unlocks reality itself? Think about what this means for our understanding of existence. If consciousness is truly fundamental, then the universe isn't just a cold, indifferent expanse, it's a dynamic, interactive system that responds to the presence of minds within it. This raises profound questions about the nature of reality. Are we merely passive observers, or are we active participants in the creation of the cosmos? And if consciousness is so deeply entwined with the universe, what does that say about the boundaries between mind and matter? These ideas might sound radical, but they push us to reconsider our place in the grand scheme of things. They suggest a profound connection between the mind and the cosmos, a relationship far more intimate than we've ever imagined. And as we ponder this, it leads us to the final sign, a revelation that ties together all the strangeness we've explored so far, revealing just how deeply intertwined consciousness and the universe truly are. Now, let's take a moment to reflect on something that lies at the very heart of our exploration, the search for meaning. The universe, with all its strangeness and complexity, doesn't just challenge our scientific understanding, it also stirs something deeper within us. It invites us to ask profound questions about our place in the cosmos, our purpose, and the nature of existence itself. Why are we here? What does it all mean? These are questions that have echoed through human history, and they're just as relevant today as we peer into the vast expanse of space. Think about it, every time we discover something new about the universe, whether it's the mind-bending reality of dark matter, the eerie silence of Fermi's paradox, or the sheer scale of cosmic voids, we're not just uncovering facts. We're grappling with ideas that push the boundaries of what we thought was possible. These discoveries don't just fill gaps in our knowledge, they reshape how we see ourselves and our world. They remind us that the universe is far stranger, far grander, and far more mysterious than we ever imagined. This quest for understanding isn't just about science, it's about something deeply human. It's about curiosity, wonder, and the drive to make sense of the unknown. Take, for example, the way we've always looked to the stars for answers. Ancient civilizations saw constellations as stories, as maps, as guides. Today, we use telescopes and particle colliders, but the impulse is the same. We're searching for meaning in the patterns we find, trying to connect the dots in a cosmic puzzle that's still far from complete. And here's the thing, this search isn't just about finding answers, it's about the journey itself. Every time we uncover a new piece of the puzzle, we're reminded of how much we still don't know. The universe doesn't just reveal its secrets, it humbles us, challenges us, and inspires us to keep looking. It's this endless pursuit that drives scientific discovery, fuels our creativity, and shapes our understanding of reality. So, what does it all mean? Maybe the answer isn't a single, definitive truth. Maybe it's the act of searching, the act of wondering, that gives meaning to our existence. The universe, with all its mysteries, invites us to explore, to question, and to dream. And in doing so, it reminds us that the journey is just as important as the destination. As we stand on the edge of the known, gazing out into the unknown, we're not just observers, we're participants in a story that's still being written. A story that's as strange, as beautiful, and as awe-inspiring as the universe itself. From the mind-bending concept of dark energy stretching the fabric of space to the eerie silence of the Fermi Paradox, these 25 signs remind us that the universe is far stranger than we could ever imagine. Each discovery, from quantum entanglement's spooky connections to the existence of rogue planets wandering without a star, challenges our understanding of reality and forces us to rethink what's possible. The cosmos doesn't just defy expectations, it shatters them, revealing a tapestry of phenomena that are as beautiful as they are baffling. What's truly awe-inspiring is how much we still don't know. Every answer we uncover seems to lead to a dozen more questions, pulling us deeper into the mystery. The universe isn't just a place of stars and planets, it's a playground of paradoxes where black holes warp time and entire galaxies might be made of antimatter. These discoveries don't just expand our knowledge, they humble us, reminding us of how small we are in the grand scheme of things, and yet this strangeness is what drives us forward. It's what compels scientists to peer deeper into the void, to build telescopes that can see farther, and to dream of technologies that might one day let us travel to the stars. The universe isn't just a mystery to solve, it's an invitation to explore, to wonder, and to marvel at the infinite possibilities that lie beyond our current understanding. As Carl Sagan once said, somewhere something incredible is waiting to be known. That's the spirit of discovery that keeps us looking up at the night sky, searching for answers to questions we can barely articulate. The universe isn't just strange, it's endlessly fascinating, a place where the rules of reality seem to bend and break in ways that inspire both awe and curiosity. So, what do you think? Are there mysteries out there that we'll never fully understand? Or is every strange phenomenon just a puzzle waiting to be solved? Let me know your thoughts in the comments below. I'd love to hear your take on the universe's strangeness. And if you found this journey through the cosmos as mind-blowing as I did, don't forget to hit that subscribe button and ring the notification bell. There's so much more to explore, and I can't wait to dive into the next cosmic mystery with you. Until then, keep looking up, because the universe is stranger than we can imagine, and it's waiting for us to discover its secrets.